Factoring polynomials of the form ax squared plus bx plus c. Keep in mind, you may have already factored expressions or equations that look similar to this one. The main difference is that in this case, our a does not equal 1. So, list all the multiples that produce a and break into parentheses in the form, so two sets of parentheses. Next, list the multiples that produce c. Finally, by trial and error, place them in the form dx plus e in one parenthesis, and the other set of parentheses fx plus g, where d and f are multiples from a, and e and g are multiples from c. So we have a couple of examples in this case. So let's start with the first one. 4x squared plus 13x plus 3. And we got to find the multiples that produce the 4. It's the one that's in front, very front, before the x squared. So multiples that produce, and notice that it's a positive 4. If it was a negative 4, then we would put a negative. So multiplied gives us positive 4. And we are also looking for the multiples that produce the constant 3. It's the one that has no variable, be aware of that. So, and it's a positive 3 as well. If it was a negative, we would include the sign. And now we check. Multiples that give us 4. Let's see, 1 times 4 will give us 4, agreed. And also one more. 2 times 2 would give us 4. I do believe that's it. That's all the multiples that give us 4 with exact numbers. And multiples that give us 3, 1 times 3. Well, it's not too bad. We don't have that many, which is great. This format goes through trial and error, which is great to have. The less options, the better. Okay, so in that case, we're filling in 2 sets of parentheses. Notice I'm leaving some space before the axis. That's to place the multiples that give us the 4. So let's randomly select the 1 and 4 first, because it's there first. I could have selected the 2 and the 2. Be aware of that. So I just write the 1 there first, and I write the 4 there now. So I used the multiples of 1 and 4. 1 times 4 gave us 4. And in this case, we have no other option for the multiples that give us 3 other than 1 and 3. So filling in the 1 and the 3 in that order. And this is just random placing. Now we're going to check. So notice, the ones that gave us the a value, the 4, always go before the x. Agreed? The ones that gave us the c values go after the x. They don't have an x on them. And now we basically check by expanding or distributing, right? So 1x times 4x, 1 times 4 is 4, x times x, 4x squared. And 1x times 3 gives us 3x. We're done with that first term on the first set of parentheses times everything on the other parentheses. So let's go to the next one, the 1. 1 times 4x gives us 4x. And 1 times 3 will give us, well, 3. And now we simplify to check and see if we got the exact same expression as what we started with. So the expression now becomes 4x squared plus 7x plus 3. 3x plus 4x gave us the 7x. Notice, those two middle terms is what makes the 7x, and it's what makes it critical. Is that the same as what we started with? No, it's not in this case. It's not 4x squared plus 13x plus 3. In this case, we have a 7x in the middle. So this will not work. This is the trial and error portion of this. So this combination doesn't work. Let's try this again. So trying it once again, let's set up our parentheses. 2 sets of parentheses with an x, some space before the x. And in this case, I'll do this again with the 1 and the 4. We still have one more order of placing the numbers. So I'll keep the 1 and the 4 in the same order. So I'll write the 1 and the 4 first. But I'll switch around the order of the 1 and the 3. So switching around the order of the 1 and the 3, I'll write the 3 first, and then I'll write the 1. Notice this gives us a different combination or different answer. If this doesn't work, we're going to have to try the 2 or the 2 repeateds, right? for the 1 and the 4. We're going to replace the 1 and the 4 with 2 on both of them instead. But let's see if it works. If it works, we don't have to worry about it anymore. So let's distribute 1x times 4x, 4x squared. 1x times 1, 1x. And 3 times 4x, 12. 12x. Hey, it's looking pretty good, right? And 3 times 1, 3. Hey, look at that. We expected the first and the last values, right? The 4x squared and the 3. But it's the middle terms that makes the difference. The 1x plus 12x. 1x plus 12x give us, hey, it gives us 13x. That's great. So notice that our expression now looks exactly the same as what we started with. 4x squared plus 13x plus 3. It's the same. So that means this is the correct factored form. So this works. So I'll just copy it down again. That way we can see that it's my final work and it's a little bit more clean than what I have above. And there it is. There is my answer. In one set of parentheses, 1x plus 3. Second set of parentheses, 4x plus 1. There is our answer. Let's try the next one. So we have 9x squared plus 12x plus 4. And we're once again trying to find the multiples that produce, in this case, the 9, the first number before the x squared. And it's a positive once again. And also the last number, the 4, the one that has no variable. Remember, you typically want to write them in order. That way it makes it easier to see. So multiples that produce the constant 9. 1 times 9 gives us 9. And also 3 times 3 gives us 9. I do believe that's it. Those are the combinations that we have available for multiples of 9. I highly recommend you practice your multiplication tables if you have a hard time with this. So 1 times 4 will give us 4. And also 2 times 2 would give us 4. Wonder combination, if you have repeated roots, or repeated numbers, in other words, I highly recommend you use those. Sometimes it could make it shorter, sometimes, but not always. Be aware of that. So, but why not try it, since you may have to still do them. So in this case, setting up our parentheses with x space between the parentheses and the x. That way I can write the multiples that give us the 9. And once again, I'll try in this case repeated values, the 3's. So put the 3 before the x's on both. And I'll try repeated values for the 4. Plus 2 and plus 2. There we go. 2 times 2 is what gave us the 4, right? And now we'll check just like before. 3x times 3x. 3 times 3 gives us 9. X times x, x squared. 9x squared. All right. Looking good so far. Well, we kind of expected that because of the way we set up our multiplications there. 3x times 2 gives us 6x. And now 2 times 3x gives us 6x. Hey, look at that. It's looking pretty good. That's essentially the critical values, the ones that are in the middle. So 2 times 2, we expected that to give us 4. There it is. So therefore, combining the two terms in the middle, 9x squared plus 6x plus 4. Whoops, that should have been a 12, right? Minor mistake. I'll come back and correct that. So that should have been 9x squared plus 12x plus 4. But do notice, this combination is a combination that worked. There we go. We're technically finished, other than correcting that 6 to become a 12. Just like what we have up above. So let's correct it. Instead of 6, there should have been a 12x. So there we go. Now that we have 9x squared plus 12x plus 4, we have the same expression as what we started with. Notice, we avoided several other trial and errors in this case. We got it on the first try. If we would have done the 1 times the 9, that would have given us 1 times the 9 and then 1 times the 4, for example, 2 different combinations. And then we would have had to try the 1 times the 9 and the 2 times 2. That would have given us 3 combinations so far. If we would have done the 3 times 3 with the 1 times 4, that would have given us, well, 1 more combination. So that would have been 4 combinations so far. And finally, if we would have done this combination last, we would have ended up doing 5 different combinations. That probably would have taken us at least 20 minutes, roughly. And be aware, I wouldn't have fit it in this particular small space. But thankfully, we got it in the first try. There is our final answer. Our factored form One set of parentheses, 3x plus 2. Second set of parentheses, 3x plus 2. Well, if we notice that 3x plus 2 is repeated twice. So that means we can actually combine this even further, one more step, into a single set of parentheses because it's repeated. 3x plus 2, and then parentheses on the outside with a square on the outside because it implies it's repeated twice. And now this would be technically our final answer. There we go. We finally got the full answer.